Okay, I think I may have figured out the counting issue. I'm looking at this schematic, this nice schematic that I printed off. And I was probing this when I had it together. And I was probing these guys right here, the 74s. And you can see the data lines, if you follow these D lines, they are all pulled high. Well, I was probing them and I was getting a low signal going high with little high pulses. And I'm like, okay, that's not right. You know, that's just not correct because it's supposed to be pulled high. Why am I getting that signal on there? Well, I got to looking at the back of the board. Remember, it's pin 2 is data, pin 2. And it's supposed to be pulled high. Right here is pin 2. Remember that cut earlier in my video? Let me grab something to point with. Remember I said I found a broken trace right here? That's on the data line. I think that's a factory cut. So I think I sabotaged myself when I fixed that trace. It would never count right. So I'm going to have to remove that. That is a factory cut. So if you are ever working on a computer space and you see that, leave it open. So I'm going to open that up and put this thing back together and see if we get counting right. Goodness gracious. Alright, well, I put it back together and tested it out, and unfortunately it's still doing the same thing. Same nonsense counting. Come on, get me. I guess they're not going to be able to get me. Huh. How funny. 0 to 0. Shoot me. Do it. Do it now. Oh, Lord. Let me try to shoot them. Fire. 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 I got them and it gave me 2 points. They got me and it gave them 3 points. Yeah, see, I don't know. What is going on? This thing won't count. How frustrating. All right, well, back to the drawing board. Now at least I can move forward maybe now after releasing that trace that I fixed. So I'm pretty convinced that thing is supposed to be a factory break. So, yeah. Well, back to the drawing board. I'll remove the top 2 boards and, see what... I don't know. I think what is causing this thing to count? That's what I need to really look at what's going on here, how the count circuit works. It's not just the 90s. What's triggering the 90s? What's triggering the count? So let me look at the schematic a little bit better, and I'll be back. Okay, I think I have figured it out. This is what I would expect. Every count, this thing flashes. Every count. what I did was I just got to looking at this schematic and poking around, and I came to the signal on this right here, actually, which provides the preset to these 74s, which these 74s interact with these counters up here. And this thing had just weird looking signals on the inputs, and I was like, man, that just doesn't look good. So I replaced these two 7476 chips, which I had already replaced. But what has plagued me recently throughout some of this stuff is just new chips that test good but are not good. Where'd it go? These guys. I got a new one right here that I had put in the board that I just don't think is any good. Now there is an old one here. These two were in the board, and I took these two from other boards. There was one in each board. I grabbed a 7476 from each of these boards and put them in here, and now I believe it works. So I think what I'm going to do is find out which one of these is actually really bad. It's probably the new chip is probably no good. But yeah, so I don't know. I'm gonna go ahead and just do a little swapperooski in here. And what I'm looking for is when I coin this up and hit start, is this. It should flash every count. And why do I expect this? Because this is what I saw when I was watching John's Arcade's video on his, is when he had only this board in, it flashed every count. And his counted right, so I knew that's what I needed to see. And it just turned out those chips, once again, just a bad chip. A bad new chip. So I'm going to go ahead and, like I said, do a little swapperooski, find out which one of these is actually bad. My guess is it's my new one, and I'm going to have to buy some more of these. But, yeah. Alrighty, well, let me figure that out. I'll let you know which one's bad. Okay, I put the old chip, the old original chip back in the board right there. And this is the good one. This is the bad one. This one right here is no good because this thing's doing what I expected it to do. Flash every count. Yeah. So this guy's no good right here, unfortunately. So this one's good. I'll put this one back in one of the other boards, and I need one more of these 7476 chips. So I'll see what I can scrounge up, see if I can find one. I'll be back. I definitely have to order some anyway, so I'll go ahead and do that. And see if I can't locate another one. Alright, yeah, the good news is this thing is counting correctly now. The bad news is I can't play it without that chip, without that 7476 in the memory board. Because I've lost all control of the rocket. Yeah, but at least it's counting good now. Excellent. Yeah, yeah, but yeah, without that 76 in the board right there, I can no longer control the rocket. Yeah. Like if you shoot your missile, it goes out the side of the rocket. And yeah. when you thrust, you do not move in the way you are pointing. So yeah. Alrighty. Yep. Cool though. I mean, we're really close now. So I'm gonna go ahead and see if I can't dig up another 7476 and go from there. I'll be back. All right. I found a chip, a 7476 that I had removed. That chip is actually bad. The cool thing about this is, or the fortunate thing for me, if I find, let's look at this sheet right here. Right here it says unused gate. E3 unused gate is 7476. Pin 11 and 10 outputs are unused. That is that chip. This is a dual JK flip-flop with preset and clear. And the unused gate that we don't need is the gate that was bad in that chip. Not the gate, the flip-flop. The unused flip-flop in that chip is the one that's actually bad. The one that we need is actually good in this chip. So, although the chip is bad, it's good for our purposes because we're only using one of the flip-flops in the chip. And the one that we need just happens to be the good one. So, we lucked out there. I would still replace that chip, but I just don't have any. So I kind of lucked out with that. But yeah, this one right here has half of this chip is no good. But that's okay because we don't need that half. But I'll set up the tripod on the camera on the tripod, and we'll play some computer space with no sound, of course. But all of the logic is now complete, which is great. So let me set up and I'll go ahead and play it. All right, computer space. I'm going to go ahead and turn off lights, of course. You want some of that effect. Wow, check that out. All right. And remember, I can't play this too great. I have to sit there and slide switches and stuff. But I can do all of the rotating and firing, and you'll see the count is correct. So here we go. Coin, start. All right. See, they got one on me. Two. And let me grab the other rotate. Ooh. Ooh. Yeah. Let me grab the thrust. Let's go. Let's fire. Rotate. Slow down. Ooh, come to a stop. Fire. I think I actually got one. I got my butt kicked. 2-8. play one more time. Coin, start. All right. Oh, I can't fire. Where's fire? All right. Got him. Thrust. Thrusters, activate. Oh. Oh, I missed him. I need to turn the other way, I guess. Oh, no. Collision. Got him. Got him again. Uh-oh. We were colliding. We were stuck on each other. I'm leading. I'm going to get extra play. Oh, I didn't have it turned on. Yeah. Oh well. One more game. All right. Fire. They got me. It's hard to play with these switches. Let me out of here. Oh, that's the rotate. I need fire. I'm going too fast. Oh, I got him. That was a good hook shot. Ah. I can't. I keep trying to turn the other way and I can't because I don't have that switch. Right here it is. Now I can turn this way. Now I need to turn the other way. Oh no. Ooh, I almost got him. Game over. I lost. Pretty cool. At least now we have all of the logic correct and the game actually works proper the way it should. But we have to do our sound fix. And I'm still waiting for all of these caps to show up. And then what I'm going to do is I will wire the... This is a 12 volt... It's basically a 12 volt center tap. It's a 24 volt each side, I believe, because it rectifies 12 volts. It rectifies the high side of the wave. So it's going to be 12 volts one way, 12 volts the other way, 24 volts peak to peak. And right at the center line is where it's going to chop it, and it's going to rectify the top wave, 12 volts. So I need 24 volt AC center tapped. And I have plenty of transformers around here so that I can put that too. Get that ready to go. I got to wait for these caps. And once I get the caps put in and everything, then I'll start on the sound. But logically, we are sound now. Good. Lots of work. Lots of work on this one. Trial and error with some bad parts too and stuff. And then sabotaging myself with fixing a trace that was supposed to be broken. Yeah, just dang. All right, I'll be back with the sound stuff. All right, we'll see you later. I kind of have to just put this on hold for a little bit until I get my capacitors that I bought to go into that sound section, and all of the decoupling that needs to be put into the board. All right, I'll be back. Okay, so I got out the old rusty crusty Midway transformer, and it has conveniently a 12-volt lug, 0 volts and 12. It's basically just 12 volts. I don't know why I put 0. It's a 12-volt winding. And I got that running over. I put in some quick disconnects here. And that runs into the board right here on these brown wires. And that 12 volts, and this tag is this tag had 120 volts. That is not 120. That goes to the 12 volt winding on the transformer. Do not put 120 volts on that. What we have, this is the bridge rectifier. And I think I misspoke in one of the last videos about, this is a full wave rectifier. It's not a 24 volt winding, it's a 12 volt winding. And it's rectifying the full wave. So, and then there's a 12 volt Zener diode right here, that little glass guy. That is a 12 volt Zener diode, which is doing the voltage regulating. So yeah, the AC from the brown wires comes into the board right here and is full wave rectified with these 4 rectifiers, and then it is regulated with this Zener diode to 12 volts. So we'll go ahead and, you know what, I will be right back. I'm gonna set the camera up on the tripod, and I'll be right back. Okay, so I got the meter ready to go. We're going to do a little measuring some voltages here. Alright, so let me go ahead and switch on the power supplies and everything. Okay. So first thing let's do is let's check the incoming AC. That should be on the anodes, right? There's the anode and here's the anode. Yeah, 14 volts. That's the incoming AC. Now let's look at the rectified DC. Straighten out my leads. The rectified DC would come off of here. Yeah, there's the rectified DC, about 18 volts. And then it is regulated with this 12 volt Zener diode right here, down to 11.96, 11.95, and there is your audio 12 volts. 12 volt DC. Very well. That works very good. So let me go ahead and put all the boards all back together, and I guess I can get my audio amp out, hook up my audio amp, and see if we get any sounds. Okay, just pointing out in the schematic, there are a couple. You remember how the 200 nanofarad is the same as 0.2 microfarad, and all of those original decouplers were 0.2 microfarad. And I removed all of those, and I'm replacing every one of those with a 0.1. But in the sound section, there's two caps right here and here that are 200 nanofarad. They're 0.2 microfarad, and they're actually in the audio section. They're not decoupling. They're actually coupling circuits together and coupling out the output. So I'm going to make sure that I'm going to use 0.22 microfarad caps there in those two spots to keep that as close to the original as possible. I don't have 0.2, and I'm not buying 0.2 because nothing uses those. 200 nanofarad. I don't think I have. That would be 200,000. 200,000. And I don't have 200,000. I have 22. So I'll use those guys. Yeah. But of course, I don't have any sounds because I'm missing all of those caps. And those caps, if you look, those caps are used to like couple sections together. Those are the two, those I have. See, there's a 33 nanofarad right there. These guys are missing. I think I have the 22 nanofarad in the board, but not the 33, which couples this previous signal into the base of this transistor. Yeah. And for the final output, I mean the final audio output, which is right here, I don't have that cap in the board. So there is no final audio output. Now I don't know what will happen once I put that cap in the board. I'm going to put that and that one in the board. This one couples all of this previous stuff into this, like the final amp. So nothing is coupled into the final amplifier right now. So I'm going to go ahead, I'll put those two caps in the board, and we'll see if we get any sounds. I've got the amp hooked up right now. Yeah. But of course there's no sounds right now, so, but that's to be expected. So let me go ahead and put those two caps in the board, and we'll see what we get. Alright, I printed off the board layout of the memory board, and these are the two caps that need to be that value. That one and that one. So I will go ahead and put these two caps. They are 22, they're 220 nanofarad is what they are. This says it needs to be 200 nanofarad. That's close enough. That's close enough to where it's not going to alter the sounds at all. So I'm going to go ahead and put those two in the board in those two spots, and we will revisit. Okay, I got the two caps in the board there, and those, in theory, we should get some sounds now, because that's coupling the main, all of the sounds to the main amp. And this one, what did that one do again? Yeah, we're coupled to the audio out now, and we're coupled to the main amp. So we should get something. Let's go ahead and fire it up. Oh, I heard this thing pop. That's promising. Alright, we're moving around. Alright, let me coin start. All right, we got white noise. Keep in mind, we are missing a ton of capacitors. So the sounds are going to be jacked up, but I'm just happy that there is sound. It is coming through. When I thrust, okay. Yeah, that's cool. We do have sound coming through, but we're missing, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 capacitors in that section. Yeah, and once the game is over, it turns off. So that's promising. I just gotta wait. We just have to wait to get those caps. But so far, that is looking pretty good. All right. Well, we are definitely on hold now. I can't do anything until I get those caps. So we'll be back. And you know what I'm going to do? I'm going to end part 4 right now, and we will come back. Part 5 will be short and sweet. It'll be mostly gameplay, showing the rest of the caps put into the board, and gameplay with sounds and all that, and just total triumph. Yeah, this is great. This is one of my most satisfying repairs I've ever done, I think. And this is so much more than a repair. This is a darn near a rebuild, but it needed it. This thing had been in a barn forever, and you can tell by this board how rusty it was and stuff. And this cage has been abused. It's just beat up and stuff. But yeah, it is what it is. It's going to be good to go. And I wanted to talk about just for a minute about my that leakage tester. I was reviewing my video and I said it's basically a short. It's not even close to a short. That leakage tester will sense up to a gig ohm of leakage across the cap. It's basically like, now there are versions of that he has on his site that actually have LEDs that you can tell exactly where about it falls as far as resistance. It's basically like putting a resistor in parallel across these caps, but they're extremely high value resistors. It could be 500 mega ohms of resistance, but it's still resistance no matter what. If you have 100 of these things on a board set doing that, then yes, it's going to cause some issues. But it's not like it's a short, like it's short and 5 volts to ground. It's nothing like that. It's just extremely high resistance across the cap. So I just wanted to clarify that a little bit. But it's, and it is what it is. They need to be replaced if they're not supposed to leak like that at all. There's supposed to be no resistance across the cap. So we're not talking ESR. ESR is equivalent series resistance. This is parallel resistance across the cap. That's what that tests. So I wanted to clarify that a little bit. And this is awesome. And I'll come back once. Today's Monday, so my Mauser order should be here any day. Maybe even today, hopefully. But I'm going to go ahead. upload this part of the video. Part 4 is done. And let you guys enjoy that while I wait for those parts. Alright guys, we'll see you on the next and final, hopefully, part.